How many solutions? In this video, you'll learn how to determine how many solutions a quadratic has by using algebra or graphing methods. So solutions to quadratic equations correspond to the x-intercepts of its graph. If we have an equation that has two solutions, then the graph will have two x-intercepts. And if the equation only has one solution, then the graph will only have one x-intercept where the vertex is. And if the equation has zero solutions, then our graph won't have any x-intercepts at all. So let's look at some examples. We'll consider x minus 5 times x plus 1 equals 7. Prior reasons that if this is true, then either x minus 5 equals 7 or x plus 1 equals 7. So the solutions to the original equation are 12 and 6. So let's see if Priya is right. So if we take the equation x minus 5 times x plus 1 equals 7, then she says that the first parenthesis must equal 7, or the second parenthesis must equal 7. But if we multiply these together, we would get an answer of 49 and not the 7 that we want. So she wanted to apply the zero product property, but in order to apply that, the equation must equal 0 and not any other number. So Priya just mistaked what the zero product property was telling her. Now we're going to consider the equation x squared minus 10x equals 0. Diego says to solve, we can just divide each side by x to get x minus 10 equals 0, so the solution is 10. And Mia says that I wrote the expression in factored form, which gives x times x minus 10 equals 0, and ended up with two solutions of 0 and 10. So we're going to determine which student was correct. If we look at Diego's reasonings, he said he divided each side by x. So we're actually not allowed to divide by a variable because the variable might be 0. And since we're never allowed to divide by 0, it's not safe to divide by the variable unless we know what it's equal to. So Maya was correct by putting it in factored form first and then solving. In this example, we're going to rewrite each equation so that we can use the zero product property. So we have 3x squared equals 81. We just want our equation to equal 0. So we're going to subtract that 81 so that it goes to the left side and our equation is equal to 0. So we'll get 3x squared minus 81 equals 0. Now we have x minus 1 times x minus 1 minus 9 equals 5x. So we'll subtract that 5x so that we can get 0 on the right-hand side. And this will produce the final equation where it's equal to 0 now. In our last equation, we have x squared minus 9x plus 10 equals 32. So we'll subtract that 32 so we can get 0. And we'll get x squared minus 9x minus 22. Since we already had a positive 10 and we subtracted 32, the like terms will create negative 22, and now it equals 0. In this example, we're going to sketch a graph for each equation, and then we'll state the number of solutions it has. Our first equation is f of x equals x squared plus 4. Right now, it looks like it could be in vertex form if we added the minus 0 in the parentheses. We also have the a value of 1, which tells us that our parabola will go upward. We can see that our vertex would happen at 0, 4. So we'll plot our vertex there on the y-axis. And then we'll make our parabola go upward since that's what the a value told us. Since our graph never hits the x-axis, this tells us that there are no solutions to this equation. Our next one says g of x equals x times x plus 3. This one's in factored form. So let's set each term equal to 0 to find where the x-intercepts will happen. X equals 0 is already solved. So we'll solve the next equation by subtracting 3 from each side. This gives us x is equal to negative 3. So we'll put our x-intercepts at 0 and negative 3. If we expand this equation to put it in standard form by multiplying the x by the parenthesis, we'll get x squared plus 3x. And now we can see that the a value is positive 1. So this tells us that our parabola will go upward. And now we can see that this one has two solutions where those x-intercepts are. Our last equation is h of x equals x minus 1 squared. We can add the 0 at the end to put this in vertex form. So we can see that the vertex happens at 1, 0. So we'll put this on our graph. Our a value is at positive 1 again. So this tells us that our parabola will go upward. So we'll draw our parabola like this. Now we can see that the vertex happens right at that x-intercept. So this is only going to have one solution. Now for each quadratic equation, we'll decide if it has two solutions, one solution, or no solutions. Here are the three equations that we're going to look at. The first example is x squared equals negative 16. Since there's no number that we can square to get a negative value, this one's going to have no solutions. Now let's look at x times x plus 2 equals 0. Since it's in factored form, and we'll set each term equal to 0. So once we solve each equation, we should have two different solutions. Now let's look at the last one. We have x minus 3 times x minus 3 equals 0. We would set each term equal to 0, but since the terms are identical, we would just set one of the x minus 3 terms equal to 0. So when we solve this, we'll only have one solution. Now let's summarize what we've learned. Quadratic equations can have two, one, or no solutions. We can find out how many solutions a quadratic equation has and what the solutions are by rearranging the equation into the form of an equation with one side equal to 0, and then graphing the function that the expression defines and determining its zeros.